Hello everyone, welcome to my channel. Today we are going to discuss amino acid as a zwitterion, and we will also discuss about amphiprotic and amphoteric molecules. Let's start with what is a zwitterion. A zwitterion, that is also called an inner salt or dipolar ion, is a molecule that contains an equal number of positively and negatively charged functional groups. It means zwitterion एक ऐसा molecule होगा जिसके अंदर जितना positive charged functional groups होंगे उतने ही negatively charged functional groups होंगे. It means all together a zwitterion will be electrically neutral. जितना positive होगा उतना ही negative. It means net charge will be 0 on a zwitterion. Amino acids, they are depending upon the pH, they change their ionization state. At physiological pH, amino acids, they are present in the zwitterionic form. At low pH यानी acidic solutions में the alpha carboxyl group and the amino group, the alpha amino group, the both of the groups became protonated. The carboxyl group after become protonated, it is uncharged, while the alpha amino group, when it becomes protonated, it becomes positively charged. Altogether, the net charge on the amino acid at a low pH will be positive. While at high pH, that is the basic solution, both of the carboxyl group and the amino group is deprotonated. This deprotonation will cause the alpha carboxyl group to become negatively charged, while the alpha amino group, it will become uncharged. It means at high pH, the amino acid will be negatively charged. There are three conditions, that is at a very low pH acidic solution, the amino acid will be positively charged, while at high pH the amino acid will be negatively charged. At a physiological pH, that is around the pH of 7, the amino acid will be present in their zwitterionic form. So we can say the ionization state of amino acid, it varies with the pH. Let's understand the zwitterion formation with the help of this following representation. Over here you already know that carbon is tetravalent in nature. It will be bonded with 4 of the atoms or molecules at a single time. Over here I have shown you only the 2 bonding of carbon. The rest of the 2 will be with hydrogen or some alkyl group respectively. Over here carbon is attached with the amino group on the left hand side and the carboxyl group on the right hand side. At a very low pH, the carbon that is bonded, the alpha carbon that is bonded with the amino group and the carboxyl group, both will become protonated, and due to this protonation at low pH, the overall charge on the amino acid will be positive because of the positively charged amino group present over here. At the intermediate pH, at the physiological pH, the carbon will be attached with both of the amino and the carboxyl group. Both are having a positive and the negative charge, making the molecule electrically neutral altogether. And at the last, I have shown you the bonding of the carbon with the carboxyl and the amino group at a high pH. Both of the groups are deprotonated, but because of the uncharged nature of the amino group and the negatively charged nature of the carboxyl group, the overall charge on the molecule will become negative. So over here I have shown you that at low pH the molecule will be positively charged, at intermediate pH the molecule will be having no net charge, and at the high pH the molecule will be negatively charged. Okay, now what is amphiprotic molecule and the amphoteric substance? The amino acid act as a amphiprotic molecule because, as I have shown you, the molecule or the ion is capable of accepting and donating protons at high and low pH. As I have shown you earlier, because of this property, amino acids are acting as amphiprotic molecules. Now, amino acid as amphoteric substance. An amphoteric substance, it can act either as an acid or a base, which are acting as an acid or a base. The molecules are termed as amphoteric substance. The carboxyl group of the amino acid is capable to lose a proton, and amino group is able to accept a proton. Thus, amino acid can act both as an acid and a base, making it as an amphoteric substance. Okay, now some of the questions that may arise, that why glycine is a zwitter ion. The simplest amino acid is glycine, where the R group is a hydrogen. The zwitter ion of glycine has a positive charge on the amine and a negative charge on the carboxylic acid. Glycine is the simplest amino acid at a pH of around 4.5 to 7.5. It can exist as a zwitter ion with an isoelectric point of 6.1. Okay, the zwitter ions, they are commonly found in the biomolecules such as proteins and the peptides specifically, and the zwitter ions are polar and usually have a high solubility in water and a poor solubility in most organic solvents. With this, we are done with amino acid as a zwitter ion form. I hope you understand the concept now. If you are facing any kind of doubt, you can just drop the doubt in the comment section. Thank you for watching.